I can make the opening.
Perfect.
So the way this is gonna go is let me briefly introduce myself, and then I'll give the floor to you to introduce yourself, and then I'll share my screen and we will show the agenda and some slides so that we can talk, and slides will be there when we talk, some visuals. So welcome everyone. I'm Hassan, co-founder and CEO of Sensgreen. We are a smart building technology company. We are helping commercial buildings to save energy, improve operations, and improve occupant comfort with our smart building platform. And we started in 2020 in Abu Dhabi. We have offices in Italy, Milan, and Ankara, Turkey, to expand into different regions. And right now we have active projects in more than 10 countries, and more than 500 buildings are right now somehow using our platform and solution for different use cases such as energy management, of course, temperature, humidity monitoring, understanding mold risk. That's the big part we will discuss here. Air quality improvement and management is also another important topic we are offering. So with Envida, we are, for the last 3 years, we are doing a lot of projects together, and we thought, let's make a webinar and let's explain some use cases. Let's explain more about mold, and I'll leave the word to Leo, who's managing director and founder of Envida Environmental.
Good morning, guys. So yeah, my name's Leo. I'm the owner of Envida. We provide mold remediation, indoor air quality services, and indoor air quality solutions as well, throughout the Middle East, primarily in the UAE. We've started in 2013, so yeah, it's 12 years now. So yeah, so we're experts in understanding why mold grows, how it grows, and getting rid of it within our indoor environments.
Thanks a lot. So, and then let me share my screen so that we can follow the agenda and show the agenda as well. Let me share this window, and okay. So yeah, we will cover mostly Middle East discussions, but of course this is a important topic in a lot of different environments. But we will focus a lot on UAE especially. And for starter, this will be about 30 minutes, so not like too long, but maybe we'll have some more time for the Q&A. So for starter, we will explain basics of mold, why it grows, why it's a headache in buildings, especially in hotels. And Leo will explain that how we are remediating mold in 5 steps. They have a special formula in this 5 steps, and he will give us real life examples as well. We will show you some real life examples, talk about real life examples, and also I will do a platform demo. So in a building where we have sensors and where we have actual projects, I will show you how people are using that, how people are using our platform to reduce mold risk, and then we will open the floor to the questions. So as a reminder, I sent a link to the chat, so you can access quickly and share your questions on the chat, and then we will answer your questions at the end of the session. So Leo, I will ask you a couple of questions here, especially. So dew point, when I heard the dew point for the first time, it was, I think, 6-7 years ago when we've been focusing on air quality. But the more I read about it, understand, the more important it is, and why we need to measure dew point and why it's important. Can you tell us about it?
Yeah, simply because that's the temperature at which water reaches 100% saturation within a property. And why it's important for us is that water vapor can cause mold growth, but physical moisture causes mold growth as well. So when we're actually looking at sort of the first step of why mold's growing within a particular property, we always looking to understand sort of the relative humidity is an important one, and everyone sort of understands relative humidity, but dew point is one that sort of gets ignored, but it is one of the most important parts when we're actually looking at sort of why mold's growing within indoor spaces. So understanding dew point's really important to finding out why mold is growing in a particular place. But simply put, it's the temperature at which air becomes air becomes full of moisture, so 100% humidity, and when it condenses into droplets.
And one example I want to give here, especially like three water bowls or cups. So actually, it's giving us the volume. You can think it's a dew point, right? And the humidity here in all three examples are 50%. So actually, if you can look, this is relative. So all three buildings or three facilities, you can think they have the same humidity, but they could have different problems. On the top on the left, we have dew point 2 degrees, and on the right, we have dew point 24 degrees, which is a problem, despite the humidity being 50%. So it's good to observe, good to measure dew point real time, and also, of course, looking at a more technical perspective. So it moves in a way that the temperature and humidity you should cross-check. And dew point plays in a critical role that in the platform we need to also guide people that how risky their building is to the mold. That's why tracking real time will be quite important.
Definitely, and sort of to add on that, whenever we come and do a root cause analysis inspection, X hotel gives us a call and says, Leo, I've got mold in a certain number of rooms. It's important to understand that I'm only there as a snapshot in time. I'm there 20, 30 minutes inside the room, but and that could be in the morning, in the afternoon, where a lot of pressures happen throughout that day on that room. And I only have a certain window in the investigation, and from where we've really found a benefit from with our partnership with Sensgreen is to understand buildings and operations when we're not there. The more data that we collect on a range of different parameters, the more important, or the better overview that we can find on a building. And I think it's important to note on that slide before that you put on, mold grows has the potential to grow at 60% relative humidity and above. Where you have a lot of the outdoor temperatures and humidities within the Middle East are above 60%. So really what we're trying to do as sort of building engineers and building owners and operators is really to keep a refrigerator inside of an oven. And any time that the building has a weakness, and all buildings have certain weaknesses, whether by the construction of the building or the operation of the building, what we're trying to analyze is how does the external environment affect the internal environment. And when you only have certain parameters, because our parameters of comfort are probably 40% relative humidity and 60% relative humidity at the maximum, because you start getting mold growth. So you have a very fine range of comfort, of human comfort within buildings in extreme environments. So it's sort of quite a tough one to monitor and measure.
Yeah. Also, on top of temperature and humidity, we need to track CO2, VOCs, fine particles. So having a whole measurement of air quality on top of temperature and humidity gives us the full picture. For instance, PM 2.5, I think it gives a lot of insights, especially how well the filtration system's working. Because the outside PM 2.5 is usually bad due to climate, due to pollution. And tracking that indoor will also help you a lot how well your building filtrated. So what would you say that on top of temperature, humidity, other parameters
definitely.
are saying?
PM 2.5 and particulates can also sort of tell you about the pressurization of a building as well. Pressurization is really important when we look at mold growth, because typically you won't get mold growth in a building that's under 60% relative humidity and is positively pressurized. And so, but it costs a lot of money to do that. And so a lot of the buildings aren't like that, because in a way it's not realistic in the environments that we build to actually expect that. Plus, you know, if you're talking about a hotel, it's gone through a lot of operational changes for the use of the building and the space. You know, you have a guest complaint on level 34 where they say, you know, it's too cold. Okay, the engineering team goes, they change the dampers, they sort of uncalibrate the building as they go, which is completely understandable, because, you know, whenever I go to engineering offices, they're the most chaotic places going. And they're always trying to resolve guest complaints right now and right now and right now. But what happens is over time, your HVAC system, which what is the major fight against mold or against mold growth, it becomes uncalibrated, and you can actually see with looking at carbon dioxide. You look at VOCs and you look at particulates. These are really key indicators. One, for indoor air quality health, but secondly, to understand how the building's performing as well.
Yeah, this is quite interesting, and it brings me the question that, so when engineering teams or the site teams, they try to solve these problems internally, and they somehow sometimes they solve it, and sometimes they think they solve it. And I hear that a lot, that mold keeps coming back. So can we solve it permanently, and how can we prevent it happening again? So how likely you see from your past experience in the last 15 years, is it a repeating thing? And once you solve it, how can you have the peace of mind?
So the question that I get asked, probably if I had a penny for every time I get asked it, I'd be a millionaire, is how can I make my building mold free? You will never have a mold free building. Mold is a really important part of our organic life cycle. It's a really important part of what of our lives, of our environment, but we don't want it inside our buildings. That's the biggest problem. Because what happens is, and we'll talk about it in a little bit, is that it impacts human health and occupant health, but it also degrades our buildings. So whenever we do find mold, it's really important that we look at why it's growing, because mold will always grow back if the moisture isn't resolved. So, you know, if anyone hires us to do remediation, they don't want to pay us the money that it takes to remove it, for us to then come next year or the year after or the year after, and we don't want to as well. As environmental engineers, we want to make sure that when we advise and when we prescribe solutions, that those solutions are enacted. And you know, again, it comes back to our collaboration with Sensgreen, is that we're able to monitor the advice that we give. So for example, if we say that, you know, let's go to a basic, okay, we've done remediation, the mold's growing because of internal air that's coming through the HVAC system, it's too wet, and we say, okay, we've done the remediation, we've put our sensor in, our monitoring in there, we can have an overview outside of that building. We don't have to come to the building all the time, but we can see in real time how that building's performing. And I know we'll talk about the alert system later, but our clients really find this useful, that they're able to see in certain areas, you know, level 15, room 13, we've got problems. Okay, we'll instead of looking at the whole building, we look at the problem areas within that building, and the Sensgreen system allows that to happen. It gives us the information as well that we can say to our clients, all right, you know, you've got an issue in this area, have a look. Do you need us to come back and have a look and sort of partner up to why it's happening?
And I just shared the questionnaire link for new joiners. Please shoot your questions through the link, and we will answer all of them at the end of the call. So Leo, coming back to the 5-step solution you developed throughout the years, this became a proven methodology, I can imagine. And can you walk us through of this 5 steps? And also, I will ask you to explain like which part of these steps you needed IoT and you needed real-time data. And also, I'm curious, especially the number 2, the categorization. So isn't mold just a mold? So how many typos mold out there? So maybe you can enlighten us on
Yeah,
how
definitely.
this
Well,
5-step works.
there's up to 100,000 different types of mold that's been recorded so far. When it comes to our solution, I'm not clever enough to come up with this, if I'm honest. This is taken from an international standard called IICRC S520, and this standard, it's through some of the brightest minds in the world that tell us how to remediate mold and how to remediate it effectively. So this is a prescribed standard that we work to. So it's not something that we've created, which is great for us. We can just study it, get certified with it, and enact it. So to take you through our 5-step solution. So firstly, we investigate. As we've briefly talked about before, mold will always grow back if the root causes aren't corrected. So how do you know what the root causes are? Well, you investigate, and what we do is when we find mold, we investigate. We understand why mold's growing, because a building it's a multitude of systems that are all working together. So mold grows whenever those systems aren't working together. So if you're talking about the facade system and the HVAC system, there might be issues there. Pressurization systems versus gaps in shafts. So whatever it is, and even occupant behavior as well. So it's really important to understand why mold is growing, because to understand why mold is growing, we can move to the second part, which is categorization. Now, not all mold growth is the same. We have 3 different conditions that we categorize a building in. Firstly is condition 1, which is called normal fungal ecology. Now, normal fungal ecology is our aim for every single space within a building. So this is basically the same mold outside is the same mold inside, both in terms of contamination, and contamination levels, really. So what we're always looking to do is take every space back to condition 1. Condition 2 is what's called trace growth and settled spores. So this is where you can visibly see mold. Just to take a step back, actually, whenever you see visible mold, it's already a problem, because mold is microscopic. So once you see it, it's already colonizing, and it's already between condition 2 and 3. But condition 2 is that you can see visible mold growth, but it's on pause. The reason why mold was growing has stopped. You know, a common one, for example, is it's wet during the summer or in different parts of the year, basically when the season changes in the UAE. So when it gets wet, mold starts to grow within buildings, and then when it gets into the winter time, when it's a little bit cooler and the humidity is dropped, the mold stops growing because there's not enough moisture for it to continue to grow. So this would be a circumstance where it's condition 2 growth, not 3, because there's no active ingredient to keep it growing. And then we've got condition 3, which is actual growth, where mold is actively growing. We can see a direct cause, and we understand, okay, this is the cause, this is the reason it's growing, and yeah, this is condition 3. So those are the 3 conditions for mold growth: condition 1, 2, and 3. Our job as remediators is always to get back to condition 1 in a building. Once we've categorized every area of the building, we then go into scope definition. So what needs to happen within each area for that space to be condition 1. Now, this sort of rectification list, remediation plan, and scope definition, always, it changes through the building. So one issue that's affecting a certain room might not be an issue affecting another room, which obviously makes my job very difficult. I'd love to just be able to go, blanket plan everywhere that you go, but it's not as easy as that. So what we do is we understand, okay, what needs to happen in each space to get this space to condition 1, and ultimately to ensure that mold doesn't grow back. And it's important to note, where we use Sensgreen within this, we use it in the investigation part, and we use it in the rectification part and project handover. So I'll explain a little bit about that. Then we move into the remediation phase. So, okay, we've been contracted, we remediate. So again, we remediate as per IICRC S520 with sort of 2 golden key rules whenever we're doing remediation, which is protect the occupant, protect the worker, so that's our workers, and stop any cross-contamination. So all our work processes, all our work procedures have to conform to those 2 golden rules. So it's probably a little bit too much to go into it right now, but if you want to do a later one, we can do that. So then once we've remediated and proper rectification work has been done, we sort of move on to the project completion and handover. This is using Sensgreen in this part is critical, because again, there's a big investment to get to this point. If you're talking about a 400-room hotel, it's not just an emotional investment, it's a financial investment, and there's a lot of stakeholders that get involved, because mold is a very emotive issue. So what happens is that to hand that building back over to the operator means that they need to be able to monitor it, and they need to be able to understand, okay, if we've done remediation, we've done all the rectification, we've now got a plan in place, how do we make sure that that plan is kept to? And Sensgreen is a brilliant way to do it, because it's objective. The data is the data, and there's no interpretation through me where it says, okay, Leo, you've got this. I mean, we can interpret the data, but you can see, as a user, you can see that data yourself. And our clients have found that the modeling element, when it comes to understanding the building, the modeling element is brilliant, and the reporting is good as well, because from a stakeholder point of view, people can see the reports and then issue the reports to sort of whoever's in that stakeholder list. And so you can sort of to understand how that building's performing post remediation.
Yeah. So at this point, maybe let me share my screen and share a bit more the platform and the demo. So what people actually see. So our platform is sensor agnostic, and we mostly work with wireless sensors, low power sensors, so that Leo can install it in a couple of minutes, not a couple of months.
2 minutes.
So in an example project, so this one, let's say we have 53 active sensors. So what this means is we usually use gateways as well. So these sensors are communicating with the gateways, and wirelessly, mostly through 4G, we can capture the data easily. Because in these hotel environments, it's also not easy to get access from IT and get to capture all the gateway access. So the entire system, we try to be as much as plug and play. So the platform is designed to give a more overview of the building. When you first log in and add your sensors, you have the idea of your alarms, your graphs. So for instance, with one look, you can compare indoor data and outdoor data. So this is, for instance, the average of all the sensors in the building, and this is the outdoor throughout the day. So you can do this for other metrics such as humidity, CO2, and so on. And here, if I deep dive further, I can capture data all the data captured can be processed the hourly, daily, weekly, monthly basis. So for instance, if I want to understand hourly temperature distribution for the last 7 days, I can just select it on the graph. Okay, let me check the last 7 days hourly rate. And now I can easily see and understand, okay, these yellow parts are maybe not within our desired range. I can actually go ahead and define our desired range from the settings, and I can decide which ones I want to yellow, which ones I want red. So let's, for instance, check humidity. It will explain a little better. So especially people, they don't have time to look at all the devices one by one, all the data one by one. So and as you can see, usually here we are rarely under 60%. And since it's summer and outdoor humidity is out of the roof in Dubai, still this can be said it is. I think it's quite very close to 60. So it's not like 70, 75. So this can be still under control. And
I think
if I want to,
I think it's important to say on this project that prior to installing Sensgreen and prior to sort of the actions from the operator, this was actually at 80% year on year. So it's actually been reduced by about 20% through their their remedial works and their rectification works has happened here.
That's great to hear. So what we also can do is we can visualize the building in 2D and 3D. So for instance, in this model, I can see all the sensors distributed across the hotel, and I can see, hey, this is okay. Let me check the green ones are actually the ones my temperature is within accepted range. A red one is like, this is okay, 19. This is below our desired range. So let's put it as a yellow. So what I can check other parameters as well. Okay, let me check. This is quite important. Okay, let me check dew point. So dew point, as you can see, now it becomes a green in certain locations. So this is 15, it's green, accepted. This one is here red. So okay, let's take a closer look in this room. It's 20.3, so maybe something is happening there. So I can easily, with one look, get a snapshot of my entire building, no matter how big it is, so that I can deep dive into certain locations. So this one is, for instance, I can say that, okay, let me list all my rooms. And now I have all my sensors and all my parameters. So this is, for instance, I can see the temperature, humidity, dew point, design dew point, comfort dew point. So we can also create new metrics. So not only the data coming from the sensors themselves, our platform supports creating new metrics so that you can add your KPIs and track that on the platform and create alarms based on that certain new metrics. For instance, comfort delta T and delta dew point is an important metric in this project. So the client receives alarm whenever this KPI is not within their desired range. So let me try to rank all the buildings from high to low for dew point. And I can see that, okay, most of my rooms are ideal. And let me rank them, okay, some of them are not ideal in terms of dew point, so that I can easily see and capture and take the action on the specific room. So for instance, let me click that and see all the details of that specific building. So I can specific room, so that I can see now, okay, this one, there's a sensor in the return air, and I'm seeing the alarms. So as a user, I'm receiving email, I'm receiving SMS, depending on the use case, and I can do my work on this specific location. So Leo, can you also tell me that these sensors are being wireless? So you can deploy them comfortably, for instance, in the return air, or in certain locations where you couldn't access before. So what value this brings, being entirely wireless, on top of, other than easy installation. So these data points, where do you want to see them other than inside the rooms?
Yeah, so being wireless gives us a massive opportunity to customize our solution, because every single every single customer or every single operator, sorry, when they have an issue with mold, has it from a different point of view. And you know, you've selected this hotel. It's an interesting case. This is so there was a lot of facade leakage. So when we told them about our solutions, one of the things that they wanted to do was actually have sacrificial filter sensors and put those sensors within the walls. So they'd do the rectification and they would put the sensor within the wall, so that they would understand how the facade is performing for the next 5 years. And so temperature and humidity aren't really important for that, because it's going to be hot and it's going to be quite humid. But what they're interested in those spaces is the dew point and the delta and the difference between the dew point of the setting and what they're actually, or the parameters of what they want, the design parameters, and the actual that they're actually getting. So being wireless helps us to be able to customize it. It also means that we can move it as well. That's a big one. We can move it from different spaces depending on client requirements. So you know, if for example they've put it in I don't know, one part of the building, and they think, okay, actually we want to look at this area, all they have to do is tell us, we've moved this sensor from this room to this room, can you reflect it on the system? Actually, they can do it themselves. And I think going back to what you talked about earlier, we find that the operators and the sort of the stakeholders of this platform, it sort of gives them the ability to have not have sole responsibility, but to have like a partnership when it comes to it. So they find that it's easy to pass the reports on to their management. They're able to pass that report onto the sort of the C-suite, where they're able to say, you know, the operation director comes in and says, okay, where are we with the humidity issue? Well, you say, listen, I've been tracking it for the last year. This is what it looks like. And once you start building baselines of data, you can then look at sort of what will this building look in 5 years' time? What would it look in 10 years' time? You're able to sort of take yourself out of the issues of the day and look, okay, how do we improve the air quality? How do we improve the we also do energy management through this? How can we bring the energy costs down? And how do we, because to enact change means you need to monitor first, and to monitor first means that you need to get the baseline data. So once you get the baseline data, you can enact change, and once you get change, you can manage and monitor and start building best practice through. That's a long way of saying wireless.
Excellent.
Having wireless devices helps us actually to tailor all of the system to a client's specific requirements.
Speaking of sharing the responsibility, actually the reports play an important role here. So the clients, they share weekly reports, monthly reports, and they share this with the management or with the client. So for an example, I want to evaluate how my building performed throughout the last 30 days or throughout the last week. So I can select the starting and ending date, and I can generate a report. And reports actually, they look like this. So this is automatically generated. So it takes a couple of minutes. And we use machine learning to process all the data collected. So for instance, for this building, in 1 week alone, with 54 sensors, we processed more than 740,000 data points, which is not possible to find a meaning with the Excels, with the exporting the data. You can still export, but this gives you all the quick summary and insights of what is going on in your building in the last 7 days. And here, throughout the standards we defined on this platform from the user's requirements, we assign automatically performance scores. So the temperature here is 4 stars, which means almost perfect, but there's still room for improvement. Humidity is 2 stars, so there's room for improvement. Dew point is 3 stars. So even if you don't need to look anything else in this report, they actually look at these stars week by week. Okay, I improved my humidity from 2 stars to 3 stars. Okay, it was 3 stars last year. I moved to back to 4 stars. And actually, I remember the first reports in this building. It was actually 0 stars on the humidity. You're absolutely right. Now, at least we have 2 stars, and in the winter, I can imagine we will see maybe 4 stars in this facility. So here, some actions and recommendations. So I talked about the machine learning. So this is important. We identify each temperature data points. So we collect data every 5 to 10 minutes from each sensor, so that I can understand this report. Thanks to this report, what is the set points in this building? So where these sensors saturate during the day. And these sensors are probably towards the outside of the building, and they have the highest set point during the day. So I can understand, okay, these buildings, these locations are my set points. And also I can understand the isolation rate. So how much temperature these sensors, this room, this specific zone is losing per hour, so that how stable the temperature is. So I'm losing that. I can identify if there is any leakage risk in these certain locations, and so further insights if the working hours, if the temperature is stable, if the humidity is stable, and which each parameter I can get the heat maps. I can get further comparisons. So I can get, okay, for the last 7 days, what was my lowest temperature rooms? Okay, this fresh air units, naturally, they have the lowest, and these, they have the highest. And also some recommendations and heat maps for each metric and temperature. And I can easily say that, okay, some rooms are actually very good. The return air, and I can compare it with fresh air units as well. And dew point, with one look, I can say that, okay, working hours average is 15.98. That's actually very good. Quite good improvement compared to last year or 6 months ago, despite being summer. So I can quickly download this report and share with the management or with my client on weekly and monthly basis.
I think it's
So
important to note here again, the tailoring of the system. It's really important because every single operator, and actually every single person that's a stakeholder within a particular monitoring project, they want to see different parts. I might want to monitor humidity. Someone else might want to monitor dew point. Someone else might want to monitor certain rooms, not just a parameter, but a certain area of a facility. So where the system works, and it's brilliant, is that you can tailor these reports. If I wanted to see dew point, but Hassan, you wanted to see a certain area, and someone else wanted to see CO2, for example, because it directly relates to their function.
yeah.
You can tailor this report to customize everything, even down to what you want within that report. Obviously not the specific data, but the layout can all be tailored to what someone wants to see. And I think that's really important.
Absolutely. So to use time also effectively, I think we are out of time a little bit. But to close the conversation, and we'll have some time for the Q&A. So I see that a lot of discussions between designing the building and operating the building, because there are multiple stakeholders. We briefly talked about that earlier, the webinar. But from your experience, so how do you bring all these stakeholders together and try to make everyone happy? Because I hear a lot of use cases where they blame each other, and then the building ends up in mold or bad conditions. So in a country where, in the UAE, where we have a lot of constructions, how can we utilize such platforms to bring all the stakeholders on the same page and keep at least everyone happy? Uh, Maybe you can give some real life examples and some challenges, some happy moments or your experience.
Again, sort of as I touched on earlier, whenever mold happens, it's because of systems not working together, and those systems can also include in the construction abilities, whether it's MEP versus civil, or civil versus MEP, or the consultant versus the contractor. Anytime that we get, well, not a lot of the times we get involved, we're already involved at a sort of a highest emotional point where people have sort of they've tried to work it through, and it just keeps growing back, and everyone starts blaming each other. When we get in, we try and put the data in as soon as possible, because data is objective. It's not emotional. It doesn't care about, you know, who said what to who, and who did this, and whose fault it is, and the data doesn't care about that. The data is fully objective and says and tells you exactly what's going on. And so that's why we try and use data, because it's not us. We collect it and we interpret it, but data is logic. It's not emotion. So in those kind of situations, we try and put the data in as soon as possible, because then we can actually start unpicking and say, okay, if you did this, or how do we do this, and you know, ultimately, we don't really get involved with the politics of a particular mold project. We try and collaborate so we can fix the issues.
Thank you very much. And so as an example, I'll close up with such an example. So in such projects where we had 75 sensors, where we needed to collect all the data from different part of the building, it takes approximately 2 hours to deploy all the sensors. And we get the PDF floor plans from the building owner so that we can represent the building either in 2D and 3D. And the next step becomes, okay, you get alarms, you get the reports, so you start fixing that, and you start understanding how you fixed and what Leo fixed, and try to protect your building for a lifetime, not for a couple of years. But the more data you have, I think the better actions, better decisions you can make throughout the building's life cycle. And
and sort of, as I said before, whenever, not just us, when anyone goes to investigate anything, they're there for again just a snapshot in time. They're there for 20 minutes, but the data allows you to, like you said, 700,000 data points within a week. We would never be able to capture that manually. No one could capture that manually. Yeah. So the benefit is you're able to see how a building works in real time.
That's I wouldn't say it better. And thank you very much, everyone. Let's open the floor for the questions. And here are our websites and emails of me and Leo. You can always reach out if you have questions, projects to discuss, and of course, feel free to reach out anytime if you want to understand more or deep dive into mold topics in more details. Thank you for joining. So we have some questions. I will open up the floor.
Hard questions, please.
I have one hard question for you. One viewer says, I've seen cases where a room passed visual inspection, but it turned out to have mold issues later. So what can we catch these, or how can we catch these earlier without inspecting every single room?
So whenever we investigate an area, we have to understand that we can't demolish the room. I mean, we can demolish the room if they allow us to and they want to pay for it. But ultimately, we can only see what we can see. There's two major parts of data collection. One's incidental data, where it's, you know, you'll come in and you'll see it. But then there's a data collection of okay, you know, sorry, so we go in and we say, okay, look at the air conditioning. We look at sort of the weak areas within a room and we try and check it out. But then there's an element of investigation where we don't know what we don't know until we know about it. So we try and use like thermal imaging, moisture testing to really try and get behind the surface to understand, okay, what's happening beneath the surface that could impact the room. And with 15 years of experience, we're typically able to diagnose quite quickly what's happening within that building.
Yeah, so I can
like I said
imagine
earlier, every room's different. So if you have a situation where you visually nothing looks untoward, and then you start having issues, it's
so not every room will have the black model hanging out there, and I'm sure you have a lot of interesting gadgets. You mentioned thermal imaging.
Thermal imaging is one that we rely on a lot. But like even just your senses as well, going in, understanding with a smell, does it smell bad? These kind of like the using your senses to understand the building as well. It's really important to understand particular rooms. If you walk into one room and it's boiling hot, you've sensed that it's hot. So there could be something. You walk into a room and it smells. Again, that's a key indicator of something going on. And then visibly, if you see mold, it's an issue.
So another question, maybe this is coming to me. Does the platform offer guidance after an alert, or just send the raw sensor data? So it offers guidance. So let's say if you have a temperature alert, or if you have an email alert, if you have a dew point alert, we usually send an email with 4 or 5 steps. Like, okay, you can option A, you can do this. Option B, you can do this. Option C, you can do this. So 1, 2, 3. And if it repeats, we send you a different alarm. So if it's a repeated alarm, we're not sending you the same email every single day. We send you more enhanced, more prescriptive emails as if this alert repeats. Also, we can send the alarm via WhatsApp, email, SMS, or we can create a ticket in your internal system as well. So we can even customize these alarms and alerts according to the facilities requirements. So we've done that in the past. So we're quite flexible there.
I think the sorry to jump in on your question, but I think it's exciting, the sort of the next version of that, where we incorporate AI into troubleshooting particular areas. So for example, from our point of view, someone goes, we've got high VOCs in this room. Can you give me some areas to look at? And so what happens is that the next version of the system will really be able to help us diagnose quite quickly how we can respond to very specific parameter sort of alerts.
One question from David saying that the system rolled out into a residential setting, or the cost typically inhibitive, and is the presence of a BMS mandatory? Maybe I can comment on this and you can add your points, Leo. So BMS is not mandatory, and actually BMS usually don't capture all the insights we can capture, because most of the BMS out there is providing a static value. So you can see the latest data, and if you're lucky, you can see a graph of your temperature. But as I said, like more than 700,000 data points, you can analyze it within a week. So you can go beyond BMS. And also, of course, being entirely wireless, you can capture data where BMS cannot. So this, you can consider that it's either a BMS add-on solution, so it's a supporting system on top of BMS, or if you don't have BMS, people usually use it as a BMS system as well, because we can also introduce solutions such as controlling these FCU units, controlling the air handling units. So we can do even more technical stuff. So if you don't have any BMS, it doesn't stop us. If you have a BMS, then we play as the role of supporting system of your BMS, because they are usually static. And David has a follow-on question. So how new or old is technology? So this is a quite, the company is 5 years old. So we started the company 5 years ago. And as of 2022, 2023, we started commercializing our solutions. The more building we had a chance to improve our reports, our alarms. We got a lot of feedback. And the technology of low power devices is also quite new. So over the last 5 years, these technologies are emerging and still improving. So day by day, they are getting new sensors, more power efficient sensors, sensors that can send further to gateways or capture more parameters. So this is an emerging technology, I can say. And one thing, maybe I can pass this to you. I think David asking about like the cost estimations and like how the cost, for instance, is it suitable for residential settings, or is it recommended only for large buildings? I think we are quite flexible there, but maybe Leo, you can explain that.
Yeah,
How does would
yeah,
work in residential versus large building in
yeah,
terms
and
of cost perspective as well?
again, it sort of goes back to your other question about it being wireless, and you know, the fact that it is wireless means that it's cheaper, it's flexible, you can tailor it. So yeah, residentially, I've got one in my house as well. So because obviously, as an environmental engineer, I want to find out what's happening in my own space with the air that my kids breathe. So yeah, I've got one in my house, and it's relatively inexpensive, really. The technology's in the platform. It's not necessarily within the hardware that gets installed. So yeah, it's very flexible.
Yeah.
You could any data that you want to monitor, you can put wherever you want. So yeah, we've got projects that are residential, we've got projects that are commercial, and it can be used wherever. The only thing is that obviously the larger the project, just by economic volume, they would pay a cheaper price because they've got multiple sensors. So that's probably the biggest sort of from a financial point of view, the biggest difference. But in terms of the technological difference, it's exactly.
Yeah, I can also say it's quite um, flexible. Okay, David, thank you very much for your questions, and we'll reach out to you to discuss this further. And Leo, I think we don't have any other questions. That's
I'll take that as I've answered
wrapping
every
up.
single question about mold
Yeah,
already.
yeah, and I think we still have a lot of people in this call, and I want to thank everyone joining this session, and hope you enjoyed it. If you have any other questions, please shoot out your messages, and also we will share the recording with you and on YouTube, and the slides also, I guess. And we'll be doing these webinar series more regularly, so feel free to join the next editions as well. And Leo, thank you very much for informing us.
Yeah, thank you for having me. If you want to get in contact with us, our number is 0436179949, and yeah, you can contact us on leo@envida.ia.
Yeah, I'll also share your phone number, and WhatsApp
My
number.
Instagram is no.
Yeah. So I hope I was a good host as well. And
no, brilliant.
Okay.
Thank you
everyone. Thank you, everyone. I'll now end this call, and have a great rest of